This is the last question, and it's a question from May 2009, A2physics 5. Question 1. Two capacitors, C1 of capacitance 2 microfarads and C2 of capacitance 8 microfarads are charged, so that the energy stored in each capacitor is 5.76 by 10 to the minus 4 joules. This energy remains stored in the capacitors as they are connected in the circuit of figure 1.1 with the switch S open. Calculate the potential difference across each of the capacitors, and remember the switch is open at this stage. So the information that you've got here is the energy stored in each capacitor, and so therefore you have to work with that equation. So the equation we're going to use is E is equal to half CV squared. Just put this up. E is equal to half CV squared. And so for the first capacitor, V1, so E is equal to half CV squared. So if we need V1, we have to rearrange that equation, and that's going to be 2E over C and then the square root of it. So V1 is going to be equal to the square root of 2C over, 2E over C. Okay, so it's 2E over C. So for each one, this is what we're going to do. So for V1, it's the square root of 2 by 5.76 by 10 to the minus 4 over 2 microfarads. And that comes out to be 24 volts. And then V2 is the square root of 2 by 5.76 by 10 to the minus 4. This time it's over 8 microfarads, and that comes out to be 12 volts. And so the potential difference across C1 is 24 volts, potential difference across C2 is 12 volts. Part B of the question. The switch is now closed. Find the potential difference between the terminals X and Y after the switch is closed. And so what you have to do is calculate the two different charges on each one, and then calculate the total charge and calculate the total voltage then. So this is a difficult enough question, so it's worth your while looking at this. So first of all, you can calculate the total charge across C1 originally. The total charge across C1 is C1V1, which is equal to 2 microfarads times, it had a voltage of 24 volts across it, and therefore it's got a charge of 48 microcoulombs. Q2 across the second capacitor is C2V2, which is equal to 8 by 10 to the minus 6 times 12 volts, and that gives you a total of 96 coulombs. So therefore the total charge equals Q1 plus Q2, and that's equal to 144 microcoulombs. The total capacitance, because they are in parallel with each other, you just add them. So it's 2 plus 8 micro, and that gives you 10 microfarads, and therefore the total voltage is going to be Q over C, and that's 144 over 10. They're both micro, and that gives you 14.4 volts. Now, it says describe and explain the transfer of charge between the capacitors after the switch is closed, and there's 4 marks. So this was a pretty horrible question, I would say, last year. But if you've met this once, if you do meet something like this again, you will be able to do it. So explain the transfer of charge. So first of all, you're going to say the total charge. So it's a total charge remains constant. But the one which has more charge, which is capacitor C1, no, that's not right. It's the one which is a higher voltage. So C1 has higher voltage So therefore charge moves from it to C2. Okay, if I just write down here, C is equal to Q over V. And therefore the one which has more higher voltage is the one with the smaller capacitance. Do you see that? The one with the higher voltage is the one with the smaller capacitance. So charge moves from it to C2, and again from higher. So we've really said that actually from higher voltage to the lower voltage. And the last one until the potential difference is equal across both. So you have to remember that they are in parallel, and the potential difference in a parallel circuit is the same. Okay, so that's a difficult enough question there, and that's the end of it.